Alright, so we're doing the transformation equation.
Wait,
I can also bring it up on here.
it's f of x equals, and then we'll have plus or minus a number. So this is minus equals x-axis reflection. This is if a is greater than 1, it's a stretch, it's vertical, and if a is between 0 and 1, it's a vertical compression. And then we have our function here, so it can either be a parenthesis, or it can be the absolute value bracket, or it can be the square root sign, but I'm going to indicate it with a parenthesis, and this is just the start of our function. So this could be, like I said, this could be like this could be like this, it could be any of those things. And I could have plus or minus a number here. This is a y-axis reflection. And the number, this is if b is greater than 1, it's a horizontal compression, and if b is between 0 and 1, it's a horizontal stretch. And remember, for these ones, with a vertical stretch, it's getting skinnier, and with a vertical compression, so if I have a parabola is a good example. If I'm stretching it, it's going to get skinnier. But if I'm compressing it, so this would be a stretch.
Is that for vertical or horizontal?
This is vertical. If I'm compressing it, this is vertical. It's going to get flatter and fatter. And then for horizontal, if I have a parabola, when I stretch it out horizontally, it's going to get fatter. But when I compress it or push it horizontally, it's going to get skinnier. So you can see that the vertical stretch and the horizontal compression are similar motions to each other, similar transformations, and the horizontal stretch and the vertical compression are similar. So then somewhere here we have an x value, and then we have a plus or minus a number here. Plus means to the left, and minus means to the right. And then at the end we have a plus or minus, plus meaning up, minus meaning down, however many that number is at the end. So if I wanted to write an example of this, I could do f of x equals minus 2 square root of minus 1/2 x plus 2 plus 6. And I'd have an x-axis reflection, a vertical stretch of 2, a y-axis reflection, a horizontal stretch by 2. I'd move to the left 2, and I'd move up 6. So this would have a multitude of things inside of it. I could even do this.
If you did that, that would change it a lot, right?
It would change the value of like how I distribute it. I'd probably want to distribute this to the x and the 2 to get like the exact number of how far I'm moving. But yeah.
That would make it reflect off the y-axis too.
It would still, yeah, it would reflect x and reflect y. And it would be vertical and horizontal. And left and up. Okay. Let's see if I have the sheet that I gave you last night. I lost lost my copy of your sheet. It's right here. I think it's right here. Perfect. Okay. So how did the last bit, these were a little bit simpler in terms of the number of them. How did this go for people, the homework? Okay.
So I was actually pretty confused because it was almost like too simple for me, so I was like confused. Then I got the hang of it, and I went to Math Center last night, and Max Hessinger was super helpful.
I'm glad to hear that. That's really good feedback.
I was really confused with the exponents when the x was the exponent, or just like when it was to the fourth power, it could just.
Yeah.
So I've never seen
But
that.
it's not fourth power, it's just like at the curve in the bottom, it looks like kind of squarish, right?
Yeah.
Okay.
But also, for number 4, I think I wrote in the directions on there to change that one to a cubic in the directions, and then on number 8, I wrote to cross out the quartic one.
I didn't see that in the directions.
On Canvas? Interesting. Okay, so in number 1, or do you guys, which ones would you like to do the most? Which ones gave you the most trouble?
Wait, 6, 8, and
3, 6.
3.
3, 6, 8.
Yeah.
Oh,
Oh, can we do 7 and 4?
3, 4, 6, 7, 8. Okay. So in number 3 we have f of x equals minus 2 to the x, which remember this is our exponential function, which looks like this. It's been a really long time since we've looked at it. Minus 2 to the x minus
wait! I thought that was the square root one.
this one.
Yeah, the one you just drew. The parent function is.
Square root looks like this.
Oh yeah, what sheet is that?
That it says graphic organizer. Molly had it right up. Molly had it out for a second.
I have
We're
all-
flipped, like we're right behind them.
It's called graphic organizer.
Yeah, it says parent function graphic organizer.
Graphic function.
You should have it from
This
last.
is last notes or files.
This.
Oh, yeah.
Maybe it says parent
That
function.
was
Go
the
down.
whole force.
Go down.
No.
Nope, that looks like the homework. Oh wait,
So
graphic organizer. There it is. Perfect. So if you go down, keep going. Wait, up. There it is, right there.
Wait, done?
Yes.
Wait, I don't have that parent function though in mine.
2 to the x.
No, on. Oh, there it is.
I have a question.
It just looks like
Does it ever? Does it stay on 0?
Mm-hmm.
Okay.
okay. I just never knew that one existed. That was my bad.
Okay.
I think I may have looked up on decimals with that function.
So for the first one, we have an x-axis reflection, which means that I'm taking it and I'm flipping it over the x-axis. So I'm taking this function and I'm flipping it over the x-axis for all values of x is less than -4. So if I was just to draw this flipped over the x-axis, it would look something like this. Well, it would keep going at 0 for a while. Come on, art skills. It would keep going at 0 and then it would pick up like that. So if I'm looking at x is less than -4, what is the value for the y?
It just stays on 0.
Pretty much just stays on 0. So I'm going to just draw an open circle at x equals -4. 1, 2, 3, 4. Open circle with an arrow to the left. Now for the second function, it's an absolute value function with an x-axis reflection. So I'm going from looking like this to looking like this. And it's from points between -4 and 0.
So put it down 0 and -4.
Yep. So at the point -4, x equals -4, y would also equal -4. So I have a closed circle here at -4, -4. Then I'm going up here,
and then I have a closed circle here at 0. And then this expression, or this function, can be rewritten as negative x squared plus 4. So I'm taking my normal parent function, my normal parabola quadratic function, and I'm moving it up 4, 1, 2, 3, 4, and I'm also reflecting it downward. So at 1, 2, 3, 4, I draw an open circle, and then I reflect it down like that. So this is what your graph should have looked like for number 3. Good? Cool.
What was the parent
Last
function
one
though?
was like, oh,
The parent function for this one? So my parent function for this one was f of x equals x squared. Parent function for this one, f of x equals the square root of x. And my parent function for this one was f of x equals 2 to the x. So then in number 4, this will probably be a lot easier if we switched it to a cubic. But we have g of x equals negative 6 if x is less than negative 2. And then we have x plus 1 to the third if x is greater than or equal to 2. So
X plus 1 to the 4th. I think it's to the 4th.
yeah, it says to the 4th on my directions on Canvas. I'm sorry if it didn't show up on your page. I only published.
I don't think I saw it.
Okay, you did see it?
No, I said I don't think I saw
Okay.
it.
What was it supposed to be?
Change that quartic to a cubic. So instead of x to the 4th being the parent function is now f of x equals x to the 3rd, which looks like this.
If it's to the 4th, would it be a circle?
No, it's like it looks kind of like a quadratic, but it's got like a flatter bottom.
Can you go over
Oh,
this
that makes
so
sense.
I can see if I got it right?
Sure. Alright, so for this, if it's 6, if x is less than negative 2, I'm just going to go over 1, 2, and down 6, 1, 2, 3, 4, 5, 6, and draw a closed circle, or an open circle here, and an arrow to the left. And then for this second function here, the way that I'm going to find my y coordinate is I'm going to plug 2 in for x, so I get 2 plus 1 to the 3rd, or 3 to the 3rd, which equals 27, which is super high.
Wait, why is it?
It's a negative 2.
Oh, negative 2. That makes a lot more sense. It's like, that does not look like what the graph looks like. So negative 2 plus 1 to the 3rd, it's negative 1 to the 3rd, which equals negative 1. So I have a closed circle here at x equals negative 2, y equals negative 1. And
Why is it is below the x? Is below the x or above the x?
here, it's below because negative 1 times negative 1 is positive 1, times negative 1 again is negative 1.
Why is the x to the 4th?
Because in my directions on Canvas, I changed it to a cubic instead of a quartic.
Oh. Okay.
Yes. So for this one, I'd normally draw, it's moved over from this to something like this. So it's going to look like, how am I going to draw this effectively? And then erase that. And if it was a quartic, I'd have an open circle or a closed circle here at positive 1,
Oh yeah, that's what
and it would be like kind of flat enough like
Okay,
that.
that's like the. I think I did it right.
Okay. Number 6. We have h of x equals 2 to the x, 3 over x. X is less than negative 3. X is greater than equal to negative 3. So here I have another logarithmic function, or exponential function, the opposite of logarithmic. So my first parent function looks something like this. And so if it's less than negative 3, I'm going to have an open circle here, and then essentially a line as close to 0 as I can get going to the left here. And then here, it's my reciprocal function, but I'm stretching it by 3, so it's kind of getting a little bit more steep here. I stretch with my normal flat, but it's for everything greater than or equal to negative 3, so I can draw this one just as it is over here. And then here, I have a closed circle at 1. And it looks something like that there.
This is 6. What is the parent?
So this is the parent function for my exponential. This is my parent function for my reciprocal graph. 1 over x. And I'm vertically stretching by 3. So I'm kind of like making it, I'm trying to make it steeper so the points kind of pull away from the 0 point a little bit more here. Number 7 and then number 8. So, you guys okay if I erase this? So for number 7, I have w of x equals absolute value of x over 2, which I can rewrite, remember, as 1/2 times the absolute value of x. If x is less than or equal to negative 4, then I have the square root of negative x. If x is between negative 4 and 2, and then the absolute value of x minus 2 if x is greater than or equal to 2. So for this first one, I have a vertical compression by 1/2, meaning that I'm mushing it down by 1/2. So I go from having my absolute value parent function, which looks like that, it would be about twice as fat. Let's see if I can get this on a graph for you guys. This would be like this instead. So if x is less than or equal to negative 4, I'm going to have a closed circle here, and then I'm going to put in this x value to find my y value. So it would be the same as 4 over 2, so it would be a closed circle at x equals negative 4, y equals 2. And it would look something like this. But I'm not done yet. Oh, I'm sorry. It would look like this. Other way. Obviously, it would go this way. I'm sorry.
Wait, what number is this? 7?
This is number 7. So my first one, if I had drawn it out, like if I had drawn the entire function out, it would look like that. But because it's only x value is less than or equal to negative 4, it goes in the left direction, the negative direction.
Can we also do number 2?
Sure. So my second function here is negative x. So I have the square root of negative x. Normally my parent function looks like this. Square root of negative x, that's a y-axis reflection, so it looks like this.
Connected the point, right?
Here.
Yeah.
So
in order to figure that out, I'd have to plug in -4 for here. So it would be at -4 and 2. So it'd be an open circle at this point.
Yeah.
And then my second point would be at here, and that square root of x for 2 doesn't exist. So there'd be a massive gap once it hits 0.
Okay, I was pretty sure that's what it was.
Yeah,
and then
that's
I was
like what I
confused.
draw.
So there's a gap. Because you can't have any x values here that are positive numbers or numbers greater than 0, because then this becomes imaginary.
Mm-hmm. So there's also open circle and a closed circle.
So there's an open circle or closed circle at 0 and an open circle at -4 and 2.
What's the parent function supposed to look like again? Okay. Alright, that makes sense. Thank you.
And then this last one, I have an absolute value of x minus 2, meaning I'm taking this original and I'm moving it over 2, so it goes like this. And so it would look something like if I plug in 2 here, it would be at 0, so x would equal 2 and y would equal 0.
Yeah.
So there's a closed circle here,
Yes.
and then a line going up like that. And then in number 8, in my directions on Canvas, I told you to take off or X out the middle quartic equation. So you just graph these two functions of the absolute value of x minus 3 for x less than 1, and the square root of 4x if x is greater than 1. So for this one, I have an absolute value function, my parent function. The absolute value of x, which looks something like this, the v. I'm getting like progressively worse at drawing these. But I'm moving it to the right 3. 1, 2, 3, so this is my new one. And it's for values of x is less than 1. So in order to find my y value, for this domain restriction, I have to plug 1 into the equation. So it would be the absolute value of 1 minus 3. 1 minus 3 is -2. The absolute value of that is 2. So at x equals 1, y equals 2, open circle.
At x equals what? Sorry.
At x equals 1, y equals 2. So my open circle is at this point here. And I know that I have to go down to 3, 0 before I can go up again for this function. So when I draw this, I know it's just going up like that. Because my turn for this equation, which is normally at 0, 0, is now at 3, 0 because I've moved it over to the right 3. So that's what this first one looks like. And then for the second function, the square root of 4 times x, I have a horizontal compression by 1/4, which means it gets steeper by 4, or it gets less wide by 1/4. And so my normal parent function for this looks like this. It's getting steeper. And so for this, I have x equals 1 again as a domain restriction. I plug 1 into this equation. The square root of 4 is 2. So I have an open circle again here at 1, 2, and I draw my graph off of that.
Wait, I have a question. Why don't you just, why is it 1, 2? Why is there not just like, I don't know.
So because I know I'm going to have an open circle somewhere along this x equals 1 line.
Yeah.
But in order to find exactly where it is as a y value, I have to plug 1 in to the formula to get the corresponding y value.
Okay.
So when I plug 1 into this function, 4 times 1 is 4, the square root of 4 is 2.
Is that just always how you find the corresponding y?
Yes. So you guys should have something that looks like this. Cool.
So if x is equal to 1, then you'll just draw a line like that.
Yeah, if x was equal to 1, it
You
would
don't care. You don't need to care about the function. They give you.
if x was equal to 1.
Yeah.
Yeah, I mean, it's an undefined slope, but x isn't equal to 1 here. Like this is the line I'm looking for coordinate points along, because I know that this is the point where it's this function less than this point, and it's this function for more than this line if x equals 1. So this x equals 1 line is kind of the boundary for the domains for both of these functions. You wanted number 2? Okay. Last one. Then we're going to start something new and fresh and fun. New, fresh, and fun. I think you guys will like it. We'll do a little stretch break too.
What is the new unit?
You'll see. Let's make it a surprise.
Is it matrices?
No.
Thank God.
F of x equals -4. If x is less than or equal to -2, it's x minus 2. If -2 is less than x is less than 2, and it's -2x plus 4 if x is greater than or equal to 2. So my y equals -4 for all values of x that are less than or equal to -2. So I go over to -2, down to -4, and I have a closed circle here, and an arrow going to the left.
Wait. Oh, plug -2 into the. Wait.
So if I plug -2 in, I just get -4. -4 is the answer to all x's that are less than or equal to -2.
Oh, okay.
So then my second function is a linear,
Why is it -2, -4?
because this is my x value. X is less than -2. So I have a linear equation here, which is f of x equals x. Normally looks like this, but I'm moving it down 2, so it now looks like this. So at the point x equals -2, -2 minus 2 is also -4. So I'm just going to indicate it with an open circle like that, and I'm going to draw a line through -2 all the way to this line here, because when x is equal to 2, I plug 2 in here and my y equals 0. So I have an open circle here. And then in my third equation, it's also a linear equation, but I am making the slope negative, making it steeper by 2, and moving it up 4. So up 4, 1, 2, 3, 4, making it steeper by 2 and making it negative. The line would look like that. So when I plug 2 in to this equation, it becomes 0, because 2 times 2 is negative, or 2 times -2 is -4, plus 4 is 0. So I'm going to fill in this circle and then make a steeper linear line going down like that. Cool. All right, if you have questions, Math Center is great. I am around during office hours and I'm on duty all weekend. So you guys are welcome to seek me out during any of those times. Why don't we take a 2-minute, 3-minute stretch break, bathroom break. I'm going to collect your homework.
How about number 10?
Do you want to do number 10? You don't want to? Well, you can look at it and it's all linear equations. Let's see if I can get this.